So I think we're good. All right, I'm Kirk Chambers. Man to my left is Derek Rozycki. We are QA engineers. Testing doesn't get a whole lot of presence at developer conferences very often, so it's exciting to be here. And we are here to ask you a very simple question of, does it work? And really, when it gets down to it, the whole point of testing is to ask this question. Because it doesn't really matter what spreadsheets you have, it doesn't really matter how many billable hours you got, it doesn't matter how many bugs you file. What really matters is, does it work? And when it gets into a user's hand, is the app functional? And so testing is hard. And this is the can it withstand byte force test. It's really important for the force trackpad. But just a quick agenda for you all. The elephant in the room whenever you talk about testing is, of course, automation. If you're hoping for a talk on how to do automation, that's not the main focus of this. But what we are going to talk a little bit more about is how you write a test plan, some deeper analysis on common problems that we see on apps when we are testing, and then we'll just talk a little bit about a QA process and you. So, automation. Why are we not just talking to you about Espresso, or if this were an iOS conference, say like the UI Automator that they have. They've, for I think probably a good 2 years or so now, been really heavily mentioned on some of the developer blogs for both Apple and Android, so why aren't we just talking about that? Well, a lot of it has to do with big O notation, if you remember that from your good old computer science days. And one time I was playing Lego Rock Band, and they have on the loading screen this little factoid, and I thought it was kind of interesting, which is that there's 915 million possible ways for you to combine 6 2x4 Lego pieces, and that's just the most basic Lego piece for those of you who remember playing with those back in the day. So why do I bring that up? Well, if you were to try to test every one of these permutations, if you could do 1 case per second, it would take 30 years for you to finish. Probably not relevant to your app lifecycle. Even if you could speed that up to like 1 per millisecond, it's still going to take you a week to finish. If you develop a feature and it takes you a week to get feedback, you're probably going to forget the code you wrote in that full week. So really, and then also just my bold bit there at the bottom, a lot of automation tools that I've used, they will actually kill and relaunch your app in between each test case, so that just adds even more overhead. The point is, exhaustive testing using just like permutations, it's going to be impossible. Testing all of these cases, not getting it done within our lifetime. You all know this because you've probably heard of big O notation, not a great way to go. So, am I saying don't do automation? No, not at all. It's a tool, but you need to think about applying the tool, not just say, oh yeah, we'll just automate our test cases and it'll be fine. So what if there were a better way, like knowing what you're doing, modeling your app, stuff like that? And I'm really sorry, I can't get on the Wi-Fi. This is supposed to be a SpongeBob GIF, and he does the boring thing because I'm going to start talking about test cases. So just you'll have me doing it instead of SpongeBob. So let's talk a little bit about what test cases are and how you write them. And I'll even give you guys a nice visual graphic way on how I start writing test cases. Just because when you're testing apps, you can kind of get mired in the details and forget to test all of the app, but your users certainly won't. So let's take a very basic example. It's the alarm clock app. I'm sure all of you used one of these this morning. I know I did. It's how I made sure I woke up and got here. And so this isn't, an exhaustive list of everything you can do in the alarm clock, but, it's pretty basic. My mouse pointer shows up. You obviously just got an empty state here. No alarm set, obvious. You got some state here where you're turning on an alarm, and you can also have this state where you've got an alarm set and armed, or you've got a set where it's disabled. So if any of you have an engineering background, you might have heard of something called a finite state machine, and I'm going to sort of use that in order to describe this app. If you're not an engineer, you might have heard like a user flow diagram from your designers or something like that. So let's just talk about a not set state. I've got an alarm clock. Currently, there's no alarm set here on the left. Or just for this talk, maybe this would be a different state if you're actually testing it, but I'm going to count both of these as just a not set state. Why? Because no alarm is set. This is pretty straightforward, I think. And then, I've got another state. I've got an alarm is currently set state. Pretty easy. And all I'm doing here is just showing you I've got a not set bubble that goes along with these two screenshots, and then I've got an alarm set bubble going on with that screenshot. So all I've really done is taken the app, said, well, these are my two states I'm currently considering, and then, well, all right, what do you do when you have states? You go between states. So what if I don't decide to call this setting an alarm a new state? What if this is just a process that I can do on the app? And so I've got an arrow in order to go between states as opposed to a state itself. And so if you take those last slides and throw them all together, you get something that looks kind of like this. And this is where I'm starting to talk about, it's a user flow diagram or a state diagram if you're from engineering. You got over here on the left-hand side a not set state, and you got over here on the right-hand side an alarm set state, and then you just have a nice little arrow going between them. So, I mean, I think this is pretty straightforward. You got no alarms, and then you have an alarm set. If you did this for all of my screenshots, you could get something like that. You got not set, you can set the alarm, or you could cancel the alarm and go backwards. Or if the alarm is set, you can reach your time and it starts ringing. Or you could hit snooze, and then it's back to the alarm set state. Or if it's ringing, I can just turn it off and go to the not set state. Now, what is this diagram good for? Well, like I said, it's similar to a user flow diagram. You might actually already have some of these if you're working with designers. You might have comps in the requirements, things like that. Makes it pretty easy because you might already have this to start working with. Why it's good? It's got very clear and concise usage patterns. It's easily laid out what the user is going to be able to do with your app just from this diagram. And I think even more to the point, guys might be thinking, well, what if I have multiple alarms, things like that? It's really easy to tell what I'm expecting this app to do and what I'm not expecting this app to do right from looking at this diagram. So if there's more states that you want, you can easily add a whole nother state like, oh, you didn't consider that. It's very easy to at a glance see what you think an app should be doing. And then along with that, it's supposed to hit every state a user can. It's readily convertible to a good test plan, as I'm going to show you in a second. And then another important part is, from this diagram, you could probably guess what the requirements would look like if you are using Confluence or Jira or something like that. And then more to the point, you could construct this from requirements. So really, it's just a very visual representation of how an app should work. But I know the other thing about that is maybe it's not very fun to test off of that. Maybe this is a simple case with 3 states. What if you got like 500 states? It'd be very easy to get lost in the mud and forget to maybe walk down one of these branches, be easy to forget about going to all of the states. So maybe what you need is a test plan. And I used that earlier. Some of you probably know what a test plan are, but more junior devs, they might never have been exposed to test plans. So how do you write one? Well, sort of tearing my diagram apart from before, I got a not set state, and I'm going to the alarm set state. I can really just take that and say I've got a current state, I got steps to perform, and I've got a new state to verify. And from there, I really just plug in my initial state, the process, and then the new state. And I can do that really for any 2 of these line diagrams. Can go set an alarm, I can go backwards and cancel an alarm, and now I have 2 test cases. If I do that, and this slide's kind of not the prettiest one, but if I do that for the entire diagram, boom, I have a test plan. And so just looking at them side to side, you can tell. The one on the left, very easy to at a glance see what the app should be doing. If you look at it on the right, very easy, linear, straightforward test plan for you to run. Very unambiguous. It tells you what state you're in, tells you what to do, tells you what to verify. Boom, easy, straightforward. And then from there, I just have the screenshot of what maybe ours might look a little bit more. You can throw in a pass or fail column. You can throw in a completed column. This one is 10 test cases long, but once these start getting into like 500, thousands, longer lines than that, you're probably not going to run it every single time. So it provides very clear reporting on what got run, what got tested, and provides very clear reporting on what passed and what failed. And so really just some hit list items for a test plan. It easily flows out of that graphical state diagram that I used, or a user flow diagram if you had one, or requirements if you just have those. It can stand on its own. I mean, you can look at that, and I could run that, you can run that, someone who's never used your app could be able to run it, so it's very unambiguous as to what you should be able to do. That's really nice because if, say, for some reason you need to outsource the actual manual part of running QA, you can do that. Or, let's say you actually did want to start doing automation. If this diagram stands on its own, it will become a lot easier to actually implement automation and make sure that you're hitting all of your cases, not just saying, I've automated our testing. Well, what did you automate? You can automate this. Straightforward execution, talked about that. Highly repeatable. That's important because if I'm running it and an automation platform's running it, I want those to give me the same results. I don't want it to fail when I run it, and then when Derek runs it, it fails. That's not good. So these are designed to be pretty repeatable results. Reaches all relevant states. Same thing with that diagram. Since it was built off the diagram, it should. So it's not like you're going to be missing parts of your app. It provides reporting on completed versus not completed. And then this one I think is kind of important. It's not something that QA talks about a whole lot, but just in the same way developers might have a PR review process, documentation like this can create sort of a QA review process. When one guy is testing your app, the odds of missing something is greater than 0. When you have multiple people testing the app, or at least someone looking over some of these documents, definitely cuts down on your misses. So, I'm going to pass it over to Derek, but just some final thoughts is just, well, I got all these states, I got all these state deconstructions, I've made this test plan, sounds great, but where do we go from there? Like, that was a very basic alarm clock app, so I'm going to let Derek talk a little bit about, how you can dig deeper.
So what should you test? You should always make sure you're testing the happy path. Everyone is used to this is how the app should behave if we follow requirements from A to Z. That's something you should never forget. Always do it, and do it multiple times. Also try and make sure that you kind of just use your app in an ad hoc way. Just get around into it. Tap on buttons, move around, make sure that you're using it as a user might. Sometimes users just kind of get into weird states by pressing the wrong button, fat fingering things. Make sure you're doing those. We also want to make sure that we're doing negative testing. I'm going to go into a little more in a little bit, but always do what you don't expect. In the real world, you're not always going to have a perfect scenario where everything is exactly like you want it or exactly like you expect it. Your data feeds may be messed up. A user's environment may be off from what you're expecting. Also, repeat tests. Do them over again. A lot of times, race conditions can happen. We want to make sure that we don't run into those, because if you tested it once and say it passes, and then it gets in the real world and it fails for 25% of your users, that's not really the greatest thing. Also want to make sure that we're testing all levels of the OS that you say you support. If you say if you're on 4.4 and up, make sure you test it on 4.4 and up. If you use tablets and handsets, make sure you test it on both. And like I was saying, don't always test happy path. You got that Rainbow Road in Mario Kart. I bet you almost all of us have fallen off of it at least once or twice. So your users are going to fall off your happy path. They're going to get off. They're going to go in different directions. You want to make sure that you can get them back to that path, or that when they get off that path, that they're not going to get to just a black screen or the game crashes, those type of scenarios. This does not cover what a user will do or you're expecting it to do. So you kind of got to think, okay, if my grandmother uses this, what was she going to do? If I drop my phone in the middle, what could possibly happen? What could be touched? Those kind of things. Because the user's always going to find a way off your road, no matter what you do. No matter how many directions you think they could go, they're going to find another one. Negative is a positive. I know that sounds crazy, but you want to make sure that you as a developer, as a QA, as a product team, expect the unexpected to happen, because it will. Someone fat-fingered something in your data, something, your 404s, those kind of things happen. We want to make sure that we test those. Make sure that if you expect an email and someone enters not an email, that your app behaves correctly. Upgrade testing. So this actually happened in the Play Store a little bit ago. If you're having trouble with an update, just delete our app and reinstall it. Don't ever tell a user to do this. Make sure that you test the upgrade path. A user should never have to go and delete your old version and reinstall the new version. because that's just painful, and then halftime they're just not going to reinstall your app. It's just the truth. Make sure that the flow from old app to new app is good, that they're still logged in, that they can retain their user data. Those are big things for users. They don't want to have to re-enter their login after an upgrade. Like I said, upgrade, upgrade, upgrade. Always do them. Do it from a store build to a release build. Just because you tested from one dev build to another dev build does not mean it's going to behave the same way. We've run into many issues where you test from your dev build to dev build and it works just fine, but when you get in the real world, user data is stored differently. Look for the following issues. Database issues. In your new build, do you have a different database style? Are you using a different fields? Make sure that if you're dumping the database and upgrade, that you refill it correctly and it still shows the old data correctly. Remove your debug options. You want to make sure you do your upgrades that you don't have any debug options in your build, because that's the best thing. Have a debug switch that they can turn off so they never have to log in, get free video content forever. That's great, right? And the data and settings retained, like I said, if they are logged in before they upgrade, they should be logged in when they're, get to the new app. Do it and do it and do it again. Don't just assume that you did it once and it's going to work forever, because that will bite you. We've all done it. That's like that's the first thing that QA always screws up on. I'm going to tell you that right now. Oh, we tested it. Well, shit, all of our users didn't. So. And this is get to know your app. Spend some time with it. Take it out to dinner. Use it when you wake up in the morning, when you're in the bathroom, because that's what your users are going to do. The number one thing people do now when they wake up in the morning is get in their phone. They don't get out of bed. They roll over, use their phone. Do it. It's not hard. Those are things that you can do to improve the quality of your app without having a testing team. Use it when you're, like a user. Then ask yourself, well, what if? What if I did this? What if a user did that? What if my data looks like that? That's the question you ask. We always say, does it work? Well, what if? Does it work, when I did this, when I do this? It's not just, okay, we tested the requirements and it works. Well, what if our requirements are backwards? Did anyone think of this state? Did anyone think that the app would do this? Did anyone think a user might do this? Those are big questions that you need to ask yourself. Also, make sure that you're testing on how a user got into your app. So did they tap the icon from a fresh launch? Did they foreground your app from the background? Was it open via deep link? These all can cause different issues depending on where you're in an app. So if you're on a view, you background the app and get a deep link, where are you expecting your user to go to? Is it to the view it was on? Do you reload the app and go to the home screen? Those are kind of questions you need to ask yourself that can cause maybe not a big bug, but a user experience that you don't want. So you want to make sure you're testing all those paths. Like I was saying, so you have a clean launch, everything should be solid, right? Well, what about a clean launch with network connectivity that they don't have? Do you require network? On your launch, do you have to pull a config? And if that config doesn't launch, do they set a loading screen? Do they need permissions? What if a user went and disabled the permission in between launches? What kind of landing state? Does your landing state depend on a config that if they didn't pull that config, they land in a very weird state? Like I said, API states, a lot of our apps that we test are very API driven, and if an API is changed and we pull that during the launch, does it screw everything up? First launch, the 15th launch, the background of the launch, we want to make sure that you're testing it multiple times. And upgrade versus clean install, do you have a forced upgrade option that in the config, after the upgrade still doesn't work? And again, background versus foreground. And then an app deep link, where did the user come from? Was it from a notification? Was it from an email link, a Twitter link? What happens to the current state of the app they were in? What if they're in the app, they got a text message from their friend saying it with a deep link? The app is still open, so what happens when they tap on that? Hardware states. Especially for Android, there are so many different devices now, so many different screen sizes, resolutions. So we want to make sure we're testing. You're never going to test all of these. Test as many as you can, and always test on real devices. I know that almost every dev, junior devs, experienced devs will make this mistake or be in a hurry and say, well, I tested on my emulator, it worked just fine. It's not the same thing. I know we all want to think it is, but It's not perfect. So, at least once on a real device. Like it's not too difficult. It takes a little bit of time, but you gotta do it. Like I said, device size, processor architecture, screen resolution, memory. These are all things to take into consideration. If you have issues on something that doesn't run well on low memory, maybe you should think about increasing to a newer device, which are going to have better memory. And hardware states. So what if they have spotty network connection, no connection? Think about those type of things. Location services. What if they you need net location, but they turn that permission off, or they turn the location off? What happens to your app? What if the user puts their app in a low power mode? How does your app behave? And then pass this back to you, I think.
I'm just going to talk about, real quickly, a random little case study that our company ran into once. This man here is Jay. He's our CTO, and I found the most embarrassing photo of him I could. It's not that bad. He's just wearing an off-brand, Slanket, I think it's called. But he's got on our company blog, and it's a few years old now. Whoops. But it was iOS camera availability, a focus on assumptions. And this one was just fascinating to me because before I started working in QA, this was a case that never occurred to me. One of our apps was crashing on launch, only on one device, all the time on this one device, and we couldn't figure out why. And the crash logs were very ambiguous, saying something to the effect that you didn't have a camera. And we were like, well, that doesn't make any sense. Let's just open up the camera app and make sure that we can take a photo. Wait, there's no camera app. What's going on with this device? It turns out someone had gone into parental controls and turned on a camera restriction, which straight up removes not only the camera app from the home screen, but then it means you can't use the camera anywhere else on the device. And so just not a case I ever considered. You can straight up turn that off in parental controls on iOS. And we ran into this on one device, and fortunately we found it before shipping, but it's just an odd case you might think about. Your devices are owned by people out in the real world. They might do weird things like this, and you should consider them. And so just sort of a reminder that permissions aren't exactly new on Android anymore, but it's important that you make sure you are handling them correctly. They are usually denied by default, and they're granted at runtime. You get that nice little permissions pop-up modal. But then just what's really important is a user can turn those off at any point in time. I can background the app, open up settings, turn anything off, and relaunch the app, and need to make sure that your apps can handle that, because it might be someone wanting to protect their kids, and it's not great if the app crashes on them. And then I'm going to pivot a little bit and talk about how your app really isn't in a vacuum. Before, I had a nice Pokemon Go screenshot on here, but I don't think that game's relevant anymore, so I had to get some new screenshots. You can tell I'm an American because I've got Fahrenheit up in here. I wasn't in a desert. It's fine. So both of these apps are some of my most commonly used ones. I've got Uber on the left and Amazon on the right, and this is what they look like if I don't have network connectivity. And I mean, this isn't a very great UX, obviously, because I didn't have internet, but it's important to think about where your app is getting its data from. It's probably not just sitting in a vacuum somewhere. So what kind of data can your app have? Well, you can have user inner data. Obviously, you're probably going to have some kind of database, be SQLite or something like that. You might have credentials that you're storing, maybe in shared prefs. You got user defaults, you got local assets and things like that. All this that's sort of stored locally on your device. And then perhaps more interesting to talk about from a QA perspective is API data that you can get from a server. Frequently, this will be something like structured data, XML, JSON, something like that. And pick your poison. But also likely images, because those are huge, and you don't want to store those on in the APK or whatever, because that would make your app download times terrible. And you might also have just feed-based states, probably also in an XML or a JSON file. But it's things like if I'm got an order, maybe there's just an order status feed that you got. So those are important enough to call out. So you got API data. I'm going to go back to calling things states. Sorry, I'm used to being an engineer, so that's just what I do. But say a lot of apps can sort of be modeled just as going from one state to another state to a third state. What might these states be? Well, if I'm making a sports app, because a possible mobile would do a lot of those, it might be a game. It goes from before a tournament to midway through a tournament to there's a championship game to the tournament's over. Those are all different states. Or it could be something like I've got an ordering platform like Amazon or something. I can order something in state 1, and then it can be getting shipped in state 2, and then it's delivered in state 3. So this type of model works for a lot of different apps that I use. And it's important to start thinking about data stability. Let's say you're in state 1, like if you have some kind of a game presenting app like Scores MLS or something, it's possible that not all of the data is present in your JSON feeds. Maybe if you've got duplicate feeds or something, or scores coming from multiple locations, one of your feeds says like a team has 5 points, another team says it has 15 points. How are you going to handle that data stability? Is it one of these feeds trumps the other? Is it whatever got refreshed first or last? So it's not necessarily that there's a right or wrong answer to that. It's just a consideration that could impact a user. Other things are these state transitions. They can happen while the app's open, obviously, if I'm using it. But it can happen if the app is in the background, or it can happen if the app is killed. You know, if I order something on Amazon and kill the app and then get a delivery box, I should expect to see a order confirmation sitting somewhere in the app, not like the app freaking out and crashing on me. But then some other interesting things to think about are what happens if we straight up miss a state? What if I am in state 1 and the user kills the app and they straight up miss state 2? Is your app going to be able to go from state 1 to state 3? So like if you're in a sports tournament and you are sort of in the pre-tournament state 1 that hasn't started yet, you miss the first round, and now it's the second round of a tournament, is the app going to be able to update and go straight into that state? Or was the app expecting that it will get data from the first round during the first round? It's a very bad experience if, you know, I wasn't using an app for a week and now it's useless to me. So really it's just important to make sure that you can recover from, you know, that kind of a thing. The other thing to consider is what if you're using an API, you probably don't control that API. What happens if they're having a service issue and all of a sudden the state 2 data just goes away? Well, can your app recover when their services recover? And then this is something we run into with data providers sometimes. You might wind up getting this weird kind of retrograde motion going on. It doesn't make much sense for me to order something, it gets shipped, and then I haven't ordered it yet. But what if that's what the data provider has? What if for some reason Amazon has a hiccup and all of a sudden they accidentally send me a shipping confirmation and it's, oh, that shipping confirmation was wrong. We need to revoke that because it hasn't actually gone to fulfillment yet. This is more of a product question than necessarily testing, but it's important to think about and how your app will tolerate it. What happens if we go from, you know, I've ordered something, it's shipping, and then back to the it's just been ordered, hasn't shipped yet state? Can your app recover, or is it going to crash because data it's expecting is no longer in there? So, and then really to just kind of tie it together, this was also a GIF, but it's ruined right now. A lot of what we've been talking about is what you might be heard as black box testing, and the idea is you've sort of got a black box and that's your app. To contrast, white box testing would be stuff like writing unit tests, where you actually can dig into the code and do things like that. This is really more user-centric testing. The idea is I can look at the inputs, I can look at the outputs, and I can't really look at the internal of the app. You know, you're testing it like a user does. It's not necessarily the best way to test. If you're a fan of the Google developer blog, they really extol the virtues of doing unit tests. Definitely worth doing, but there's also a sort of input payment cost of actually writing all of those unit test cases. And if you haven't been doing TDD, maybe even refactoring your code to make it work, this can get you the best bang for your buck to start testing if you haven't been doing a lot of it yet. And then just, it's important to note this isn't how you unit test. This is really what we call integration testing. But a question you might have is, well, so it's great, I can use this black box model, maybe the inputs, if it's a user tapping, well, that's great for me to figure out how to do it. What if it's API data? Do I actually need to wait for them to set up an app? And this is just a trivial example, but you can see a JSON file, and I can locally on my machine edit whatever is in the JSON to whatever I need it to be, and I can run my own mock simulations without anyone else. So I could give an entire talk on Charles, but it's really just sort of a key tool to let me modify what data is coming back from an API. And then I'm just going to give it back to Derek to tie it all together.
Yeah, so to tie it back, there's a couple things we're going to go over here just to let you guys ask questions. Automation, we think it's great. We don't think you shouldn't do it. The practices we're talking about are more of how to test and what you should test, and those can be applied to automation. Everything we said here, you can automate all those things, but you need to understand the basics about what to automate. It's not just, we're going to throw automation together, it's going to solve all our problems. Here you go, Dev, go ahead and do this. So, how to write a test plan, deeper analysis on common problems, and our QA process, and you. So back to these state diagrams versus test plan. They're both super useful. They both have the same data, but are displayed very differently. One is very visual. You can all be in a room, have this on a whiteboard, and go over what states did we miss on this app. You know, did we miss a line from the alarm set to, or from the not set to ringing? Is there any way that can happen? You can discuss those type of things. On the other side, you have the test plan, which is very linear and runnable by everybody. I should be able to go into a room, hand this to 10 people, hand them 10 different phones, and say, okay, run through this. It should be very easy for anyone to read. Your test plan should not have any data knowledge or app knowledge that someone needs to run. So where does QA fit into the dev process? Everywhere. Just like how, in a perfect world, of course. I mean, sometimes this doesn't happen. Just like a PM fits everywhere, developers fit everywhere, QA should be everywhere in the process. We should be there in the beginning when requirements are written so that we can also ask those what-if questions. What if a user does this? We should be a part of your structure. We should be on your, we should be in the stand-ups. We should be in those kind of meetings. We should be discussing with you throughout the process. That gives us accountability that we can say, as a team, we've thought of all the scenarios. Everyone is a QA, just like everyone is a user, just like everyone's a designer. Everyone has their opinions. Communication, it provides a lot of communication. I hate at some places I've worked before where a QA will log a ticket, a dev will get it and kick it back saying can't see this. If you can't see it, talk to me, ask why. There are a ton of situations where you and I could be seeing different things. Our environments could be different. You could be on an emulator, simulator. So communication's huge. It provides a lot better insight into what's going on. It also gives expectations. If we're going to ship on the 12th and dev was supposed to be done on the 1st and dev is running late and you guys got done on the 11th, there's no way we're shipping on the 12th, and that when we're on the project from start to end, we can see those coming up and communicate and have expectations that we're not shipping on time or we're not going to get through the whole testing. And then crashes are bad. This is the number one thing that'll make a user stop using your app, is a crash. If your app is crashing, they're going to uninstall it. You're going to lose users. If you have visual bugs, if you have something that doesn't look quite right, like I said, if you upgrade and if they're not logged anymore, those are great bugs to have, but crashes will kill your user base. This is the number one thing that we need to fix. You need to find those crashes. You need to set up your hockey or whatever you're using to automatically create bugs in your system, because when you find those early, fix those early, you'll have less problems with your user base. Happy testing. There's our information, and if anyone has any questions, we're open to them now.